Moving on towards our next keynote presentation from our strategic partner SUSE on protecting cloud-native Kubernetes and container deployments, presented by Mr. Tshepo Masigo, Cloud and MSP Partner Executive of SUSE. Welcome, Mr. Tshepo, and the stage is all yours.
Hello, can you hear me?
Yes, we can all hear you.
That's lovely, that's lovely. Thank you so much for the opportunity. So good afternoon, everyone, and thank you so much for the audience. Today, I would like obviously to share with you what the subject has been about, which is the zero trust, about what it means for protecting the cloud native Kubernetes and container deployments. As said, my name is Tshepo Masigo. I'm responsible for cloud and managed services provider business in Africa. So basically, I look after the entire South and Sub-Saharan Africa. So my today's agenda basically is broken up into two sections. And the first one is the zero trust cloud native environments. I'll just hover over that. We've had enough around zero trust. I'll just share my insights on that. And the second part of the section will be about the SUSE New Vector Zero Trust Security itself. And I'm going to share with you how SUSE New Vector is a comprehensive security solution for any container environment. So, you know what, today is a good chance to share what we have learned talking to our customers. Before we begin, we always obviously consider what has changed, what has occurred in the last 2 years. And one major indicator we've noticed is that infrastructure perimeter has changed dramatically. I think the previous speakers have spoken that. You could also call this disappearing or blurring if you think of 15 to 20 years back when we started using the virtualization technology by moving servers, you know, to the data center. Suddenly we realized that, oh, this is the foundation of cloud technology. Think about the security measures around that before. We all have kinds of security solutions protecting the perimeter we could control. For example, we had antivirus software installed on every laptop or desktop, which can scan your storage or can scan your network, or we also have gateways. Some people have gateways for their homes today. Today, everyone has routers in their homes, which with built-in firewalls capabilities, which serve as perimeter for protecting their actually house, perimeter security for protecting their homes. But then like about 7 or 8 years ago, security technologies are now used in the cloud. For example, we began protecting the virtual machines, virtual networks, load balancers, and we have CVS enabled, you know, to protect the traffic that enters the cloud services. However, containers appeared unexpectedly. Microservices again changed the perimeter. Because containers' big advantage is the containerization itself. That is to be able to run microservices anywhere automatically when resources are available. Now that's a whole new way of utilization of resources. As a result, the new concepts and the perimeter emerge, you know, and parameters emerge. For example, how do you know about the container network and microservices communications? Or you can now have multiple clouds because this technology, like my colleague Steve just said, you know, this technology allows to have a multi-cloud strategy. Many customers are already using multiple clouds in their Kubernetes deployments. However, if you look at security perimeter, it is changing so quickly, or maybe I can say it is disappearing right now. There is no traditional method of gateway you can use to protect your serverless functions today. To protect the environment, because everything has become actually a virtual concept. So the perimeter is changing, the whole body of security must change or must be changed to fit into that. Today, an increasing number of security solutions are moving towards zero trust model, as we all know. A long time ago, we were pretty much in the reactive model, where we basically were trying to protect the, you know, known or unknown perimeters. We tried to scan the known issues of the environment. We tried to deny user via policies. We tried to figure out what bad IP addresses were, you know, I should have blocked. we could only scan all known issues in the environment. And we call this reactive security model. Basically, you can protect what you already know, or you can buy some time to, get the earliest security feeds or updates or vulnerability updates. But now in the microservices environment, it's so hard to track what's a bad IP, because IPs are dynamically allocated. When a container spins up, it will automatically get an IP, and that IP is released in hours or minutes, and it's reused in another microservices. So the reactive model of security cannot work in this dispensation. That is why the new security model was introduced, and that is called the zero trust, security, as you've been hearing. Now you cannot rely on denial list policy protection, because you cannot manually configure your bad IP address list. So you can basically use long list policy. I trust everything by default, and then use declarative way to define your application behavior. And that behavior basically is a denial list policy. In this policy, by default, everything is denied. Only the thing you are declared allowed to communicate, to talk to each other. And then nothing will rely on physical resources, no physical IP addresses will be defined in the policy. So this is a new way of doing proactive mode security. We also call that zero trust, because that's the most efficient way to scale in the cloud that allows you to do security automation, as well as protect the known and unknown threats. Forrester defined this zero trust security model in 7 pillars. Basically, you need to think about the security guidance around the 7 major assets of your organization. The first is the user. You are going to make sure that user identities are secured. Then the device, because everybody gets the device. The network, the environment, and the application and workload. And then you think about visibility and analytics of your security, so that known events and logs gives you feedback about what to improve. And I had my colleague also mentioning that. Then the last 2 others are automation and orchestration. In the data space, we all understand that to have peace in this cloud native environment, because everything was built onto the CIDC pipeline. Everything will have to be automated, and everything will rely heavily on the orchestration platform. So all those 7 pillars are the entry points. You will want to review your security posture. You want to review your compliance around that, so that high level, that's what's the practical security practice you should adopt as a start. From a security concept, what we should do, as I basically outlined, the 4 major points to protect the 7 pillars of the zero trust strategy. First, you want to minimize the attack surfaces. The second is you want to be sure you have enforcement and real time, because without enforcement, you will have enforcement in place to make sure that production workloads is secure and safe. And then you will have continuous visibility and compliance capability. And the last key point is that security itself doesn't mean you have to spend management efforts to adopt a zero trust strategy. And security can be transparent and super easy to automate and use. Those are the key points I would like to share in this section. Now we will talk about the SUSE new vector zero trust stack, how it monitors, orchestrates, and enforces workload and security policies in the next slide. SUSE Zero Trust product line is centered around SUSE New Vector product, which is a container security platform to help monitor and enforce zero trust controls that you would like to put in place. SUSE Zero Trust stack really has many products. I'm going to dive into those aspects and point out certain areas. SUSE Rancher, as the orchestration and management layer for Kubernetes, is going to be able to make sure that the Kubernetes cluster that you deploy have the appropriate RBAC controls configured. And then, of course, New Vector can help SUSE Rancher to monitor those. In addition, both New Vector and Rancher support single sign-on and can then be integrated with multi-factor authentication. And you can create role-based access controls to also be part of your zero trust strategy. Now, at a lower level, the operating system level, we have SUSE Linux, and it can be any other Linux distribution or operating system. Also, our SUSE one called SLAS, With SUSE Harvester, which is our HCI, cloud native HCI solution, it leverages advanced machine isolation technology to make sure that all organization data is safe and isolated in the appropriate environments. Then down at the data layer, the critical layer, is SUSE Longhorn, the storage solution that is integrated also within the Rancher stack. Longhorn can implement encryption at data at rest. And in addition to that, the new vector solution can ensure that data in motion, network connection, either between your application or microservices, or ingress or egress out of the cluster are also encrypted, so that data is protected when it's in motion as well. So the challenge is that those things are moving very fast that traditional security tools can enforce, you know, the microservices and Kubernetes agenda. A lot of controls that are required for zero trust, and specifically one aspect that is Kubernetes and networking aspect of it is really abstracting the network layer. So if it makes it difficult to apply traditional network visibility segmentation, even traditional security concepts like WEFs, IDS, IPS, so what we need is really a new technology for that. So essentially containers and Kubernetes virtualizes everything. So it kind of obscures the visibility into underlying host and network traffic. From that perspective, it makes it very difficult for security professionals to really see what's going on, to know that there's an attack going on. You can't rely on traditional tools, as I did mention before, like WEFs for next generation firewalls, or endpoint security in a containerized environment, because they have no visibility to what's going on. So that's a challenge, and it's in itself, it's a challenge, you know. But in addition to that, you also have new layers which present an attack surface, and that includes orchestration and other tools you are going to manage these containers with. The other challenge is that developers are not security experts, and now developers are required, you know, to partake in securing the applications that they're currently developing. So we have a kind of people issue, not just developer issue, but then you have, on the other side, you have security professionals who may understand the security attack, what a security attack may look like, but they really have no idea how a container is deployed, how Kubernetes work. So there's a lot of security challenges that this movement is presenting. Security does not require really building into the life cycle of an image or a container. So we like to divide that into two major aspects: supply chain and runtime. In supply chain area, it is important that every code used in the workload or being put through the pipeline is secured. So vulnerability scanning, compliance, and mission controls are critical, as well as to prevent unauthorized images into the runtime. And then once this are running in the runtime scanning and detecting traditional network-based attacks or threats can be maybe SQL injection attacks, etc., fall in this category. So if you haven't placed zero trust controls in any, you know, it's really the most comprehensive way that you can protect against these attacks, as well as the most scalable automatic way. I'll talk about how we do that next. So, you know, with SUSE New Vector, it protects running containers in their host with a true network application security isolation. We also solve the pain of securing containers in production, such as the lack of visibility into container connections, securing containers which are constantly changing, and the dramatic increase in internal east-west traffic. Traditional security tools secure container networks, can secure container networks, and security teams can slow down the rapid pace of DevOps releases. New Vector provides the critical features required for layered runtime protection for containers, violation of normal behavior, application threats, vulnerabilities, and privilege escalation are detected before they can result in damaging attacks. The solution is a container itself, which the New Vector solution. It doesn't require agents, no embedding into container images, and no application coding is required. It deploys in a matter of seconds for both greenfield applications and running brownfield applications. The all-in-one container provides the manager and controller for your cluster. The enforcer container is deployed on every host in aspects and protects all container network connections and application behavior. You can use container orchestration tools to deploy and manage application containers and new vector containers. SUSE integrates with all platforms and it's compatible to overlay networks. The new vector technology is based on behavioral learning of application and network behavior. A whitelist-based security policy is automatically created and enforces rules in real time. There's a built-in intelligence for over 30 applications and protocols, which enables SUSE new vector to protect true layer 7 application protection for each container. This zero configuration policy makes it possible to secure your container in a dynamic, rapid changing way. Once the new vector containers are deployed, they instantly discover and map containers and their network behavior. The security policy to protect each application stack is automatically created, isolated each applications, no matter where they are running. For example, if the customer node 3 from an application tries to connect to WordPress container, let's say, a violation alert will be generated. Or if Redis container has been compromised in an attempt, to connect externally, this can be blocked. Even the direction of the connection is enforced when node 1 tries to connect to the environment. New vector detects violations of container behavior with hosts, between hosts, and between clouds. Common application stacks such as distributed denial of service and DNS on containers are detected in real time. All running containers and hosts are automatically scanned for vulnerabilities, enabling you to assess the risk profile for applications and hosts. Scanning is super fast because it is distributed on heavy hosts. New vector also monitors containers and hosts for privileged escalations, which could result in breakouts. This is often a critical indicator of impending attack. New vector provides powerful virtualization tools for test and production environments. It is simple to filter thousands of containers down to one application stack, or even view logical relationships between applications, which consolidate similar containers into a group. This helps diagnose connections, issues during testing and help detect suspicious connections in production. New vector is the only, I can say, true network-based container security solution designed for continuous runtime protection. Think of new vector as a distributed layer 7 application firewall for all container traffic, including north-south, east-west connections between hosts. So, while it is important to do some traditional security activities such as vulnerability scanning and management, keep in mind that trying to keep up with the night list and signatures really looks like looking in the rearview mirror. You are looking at the past things that happened and trying to make sure that those things don't happen. While that is important, it is not going to protect you from from day one attack, the 0-day attack. Or if anybody has discovered a vulnerability in your environment before it was published and a CVE is not yet issued, they could have, they could be exploiting your environment for months before this was even disclosed. So how do we make sure that through things like traffic inspection?
Sorry to cut you short, Mr. Tshepo. We're running out of time, so I would request you to please wrap up. Just one more minute.
Thank you so much. So what I would want to say is that, as we hammer home, you need to be able to continuously audit the security in the stack. And that could be our back configuration in Kubernetes. That could be running a CIS benchmark across API servers and the nodes, the runtime or the images. So everything should be continuously audited because after deployment, somebody can declare a change state of your cluster, and that could inadvertently, open your environment for an attack. I hope you have enjoyed this overview of using SUSE new vector container security platform for protecting your containerized environment. Please, do not hesitate to contact me if you may require explanation around the presentation. And thank you so much. My apologies for going over time. I was trying to rush. I know we missed some minutes before. Thank you.
Thank you, Mr. Tshepo, for your valuable insights and extremely informative presentation. I'm sure that our dear participants definitely got a lot of information from your keynote. Thank you for joining us and have a great day ahead.
Thank you. Cheers, everyone. Thank you.